Hey class, Bob Greevy here again. I want to walk you through problem number 9 in your homework that I've asked you to complete to kind of show you what we're doing in this spreadsheet. Problem 9 is going to simulate the potential outcomes of a particular project that consists of 4 different activities. But what I want to essentially show you is how you can use a random number generated in Excel and couple that random number with an if-then statement, or an if statement rather, and use that to simulate particular outcomes. So let's say I just wanted to simulate the flip of a coin. What I could do is I could write an if statement. Well, first I would generate a random number, okay, using the rand statement again, equals RAND, open parentheses, close parentheses. Recall that's going to generate a number between 0 and 1. Each number between 0 and 1 has the same likelihood of occurring. And then what I'm going to do is I'm going to translate that into a particular outcome with an if statement. So an if statement lets you put out there a logical test. Is this greater than this? Is this less than this? Is this equal to this? And then if that test turns out to be true, you specify the outcome of the formula. And if it's false, there's a different outcome. So let me just explain what I'm going to do here and make sense of it as I go. So I'm going to say if in 8, that formula that precedes the one I'm typing in, if it is less than 0.5, then I want there to be an H, or I just want it to say heads to show up. If it's false, I want there to be a tails that shows up there. So look at this formula. It's the if then else. The way to read this. Oops, I want to see the formula. Okay. If this particular thing is true, then I want to see this. If it's not true, I want to see that. Does that make sense? So if the random number generated is less than 0.5, I want to see heads. If it's not, meaning it is greater than 0.5, then I want to see tails. Why 0.5? Because tossing a coin in the air gets you about 50% of the time heads, 50% of the time tails. So what I've just done is I've simulated a coin toss. And what I can do now is I can simulate by simply Control-C, copying that formula down. Oops, let me do this again. Copying both of those formulas downward, I can simulate as many coin tosses as I want. So tails, 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 heads, heads, tails, tails. And every time I hit enter after any of these formulas, it does the simulation again. So in this way, I can simulate random events. Random events. This sort of thing is how a slot machine might work, an electronic one, or how an electronic board game might work as well. So we could use something very similar to this to create the simulation of a roll of a die, and that would involve something called a nested if statement, where instead of the tails, we would put another if statement, and I'll explain that. So we say, well, let's start with a random number. Remember, that generates a number between 0 and 1. And I'm going to say equals if that number is, let's see, that's in 8. Whoops. If that number is less than 0.16, then I want to see the number 1 there. Why 0.16? Well, let me do it a little more exact. If that number is less than 1/6, then I want to see a number 1 there. Well, the likelihood of that number randomly being generated between 0 and 1, the likelihood that it's less than 1/6 is 1/6. What's the likelihood you'll roll 1 when you roll a die? It's 1 in 6. Okay? But if it's not less than 1/6, then I want something else to happen. Well, this is where we put the tails in the earlier example, but here I've got to ask more questions. So I'm going to put another nested if statement. So I'm going to say, okay, if it's not less than 1/6, but it is less than, let's say, 2/6. Okay, then I want to see a 2 there. So let me explain that real quick. So if it's not less than 1/6, but it is less than 2/6, then I want to see a 2. Well, what's the likelihood that it's going to be not less than 1/6, but less than 2/6? There's a 1 in 6 chance that that'll happen. Okay? And if that's the case, then I want to put a 2 there. If not, I'm going to put another if statement. If N8 is less than 3/6 or 1/2, but let's keep it consistent, then I want a 3 there. If not, I'm going to ask another question. Is it less than 4/6? If not, I want a 5 there. I'm sorry, a 4 there. And if it's not less than 4/6, I'm going to ask one more question. Is it less than 5/6? And if it's not, if it is less than 5/6, I'm going to put a 5 there. If it's not, I know it's a 6. And you just got to close out all these parentheses. Okay, and hit enter. Now, that's a big, hairy formula, but if you study it for a minute, you're going to realize it's not that complicated. So if we read this thing from left to right, we say, is N8 less than 1/6? Is it less than 0.16777 in other words? And if it is, we say we just rolled a 1. If it's not, we ask another question. Okay, we know it's not less than 0.1677777. Is it less than a third? If that's true, that means it's greater than a sixth and less than a third. So the likelihood of that happening is also 1 in 6. And if that happens, we say we rolled a 2. If not, we keep asking questions. Okay, so it's not less than a third or 2/6. Is it less than 3/6? Again, the likelihood of that 3 is 1 in 6. The likelihood of the 4 is 1 in 6. The likelihood of the 5 is 1 in 6. And at the end there we said, okay, if it's not less than 5/6, it's got to be a 6. We're going to roll a 6. What's the likelihood that a randomly generated number between 0 and 1 is greater than 5/6? That likelihood is 1 in 6. So what we've done is we've simulated the roll of a die where each of the numbers 1 through 6 have the same likelihood of occurring, and that likelihood is 1/6 or 1 in 6. Okay, so what I can do is I can roll this. Let's see if we can get a Yahtzee. Control C. Let me copy this whole thing. Control C. And I think in Yahtzee you got like 1 or 5. I think you get 6 die in there. Maybe that's wrong. Somebody's going to email me and tell me I'm wrong. It's 5 or 6. Okay, so I just rolled my Yahtzee and I just hit 3, 3, 6, 2, 6, and 4. So I've got 2 pairs. That's not a very good roll. Anyway, you get the idea. Let's roll those dice again. This roll, I got a pair of 6s, a 3, a 4, a 2, and a 3. I know some of you right now are going to build your own blackjack engine. I think that's fine. That'd be a good bonus activity. Okay, that's the meaning of that. Now let's interpret what's going on here. The textbook gives us the likelihoods of these different activity durations. Okay, so in chapter 12, in problem number 9, you will see that each of these activities, activities A, B, C, and D, they each have different activity times with different probabilities. So if you look at activity A, there's a 25% chance that that activity takes 5 weeks. So what we've got here is activity A being simulated by column A here. That's the random number generated. And we've said, is A4, is that random number less than 0.25? If it is, put a 5 there. If it's not, we ask another question. Is it less than 0.6? If that's true, put a 6 there. If you're asking, why 0.6? Well, we want the likelihood of a 6 showing up to be 35%. And that is accomplished by saying, okay, it's not less than 0.25, but it is less than 0.6. There's 35% chance of that happening. And it is in a similar way that we complete this formula. And I would ask you to just study those formulas a little bit if that's confusing. Maybe watch the explanation of the dice as well again. But what we've done is we've simulated an activity A, an activity B, an activity C, and an activity D that collectively make up the duration of the project. And we just add those up. So each row of this simulation, let's look at one row. Each row of this simulation is simulating one instance of this particular project. according to the activities and their potential activity durations and the probabilities of those durations. And then you'll notice we've done this many times. So what we've done is we've simulated, looks like more than 400 times, we've simulated, or exactly 400 times, we've simulated a particular project. And over here we've just taken the average and the standard deviation. So that gives us a feel for how long this project will take. Looks like it'll take about 34 weeks, and the standard deviation is 2.68 weeks. So it doesn't vary just a tremendous amount like the earlier problem 2 did. Okay, that's an explanation of how we, again, can use a simple spreadsheet to simulate potential outcomes.